Hi everyone, and welcome to the video that's following up on our first video on choosing random numbers and dealing with randomization. In this video, what I want to do is unify a lot of the previous material that we have seen this semester. So I want to write a program that incorporates loops and if statements and choosing random numbers to see the power of all these things combined. And in particular, what I want to do, I'm just going to write a single program, and I want to model how you write a more sophisticated program. So this program we're going to write here is fairly sophisticated for us right now, so I just want to give you the setup of the program. So we're going to see what the program is supposed to do, and then I want to talk through how you write the program and then actually write it. So here's the program we're going to write. It's a game playing program. So consider this sort of toy example game. You go to the casino with an initial bankroll of $8, and bankroll here, that's just a shorthand way of saying the amount of money you have in your pocket, the amount of money you currently have. So you sit down with $8, that's what you bring in, and you're going to play this game. Here's how it works. You're going to bet X dollars, and in this particular setup you can't bet more than you have, so the casino will not give you credit in this example. And the dealer is going to throw 2 dice, or maybe you get to throw 2 dice. It doesn't matter. If the sum of the faces of the 2 dice is a prime number, so 2, 3, 5, 7, or 11, then you win X dollars in profit. Otherwise, though, if the 2 dice don't roll a prime number, you're going to lose that bet. And you can play this game as long as you still have money. And every round you can bet a different bet amount if you want to. So this description here where the guy throws 2 dice and just looks at whether or not the sum is prime, that's just one round of this game. So you can play as many rounds as you want to, and you can make different bets each round if you want to. And you're going to play this game until your bankroll has grown to a pre-specified goal of B dollars. So all I mean by that is, let's just assume you sit down with 20 bucks and you tell yourself, I'm going to play until I have 100 bucks on my person. You know, the money in my pocket is 100 bucks. We're going to assume that you have self-control and you actually will leave when you reach your goal. You know, a lot of people sit down with good intentions and do not leave when they reach their goal, but we're going to assume that you will. So you're going to play until you've grown the amount of money you have to a pre-specified goal, or the casino is going to kick you off the table once they've paid you $10,000 in profit. So there's a profit cap on this table, or until you go broke. So basically you're either going to play until you win, where win maybe means getting your goal or getting a goal of $10,000, or you lose, which means that you have no money left to bet. So let's write a program that lets you play this game. And we're going to just keep track of how many rounds you played. And we're actually going to keep track of a lot of things, but let's just write a program that plays this game. So, so here's just a, in case you were confused by the setup, here's just a specific example. So suppose you sit down at the table with $100 in your pocket and you want to leave the table with $200 in your pocket. You're either going to play until you've gotten $100 in profit, or you have nothing left. If you sit down with $100 in your pocket, then you can't leave with 12 grand, right? Because that would be 11,900 in profit, and the table has a cap on winning. So you can't just sit down and leave with any amount. So that's how this game will work. Okay, so let's talk about what goes into thinking through a program like this. So one of the first things I always think about is, well, obviously the program is going to keep track of a bunch of different things, right? And you need to store those things somewhere. So what variables do I need? What do I need to record? Well, here's just sort of a laundry list here. So it seems maybe obvious you have to keep track of how much money you have, right, your bankroll, because you at some point need to know whether that has shrunk to 0 or grown to your winning value. You need to keep track of how much profit you've made so you can know when the table kicks you off if you've made too much profit. You should probably store the amount of money you're aiming toward. You know, if you start with $100 and your goal is $200, it seems reasonable to store that $200 somewhere. You need to be able to update the amount of money you're betting on a given round. So we need a variable to store our bet amount in a given round. We're going to throw 2 dice, so we need 2 variables for each of those. Sorry, we need 1 variable for each of those 2 dice, so 2 variables total. We don't have to, but let's have a variable for the sum of those faces. And we're supposed to keep track of the number of rounds, so let's have a variable for the number of rounds. So here's just kind of a, like, I don't know what you call this, just ideally I suppose you would draw a flowchart or something, but here's just an English description of what will happen. As long as your bankroll, the amount of money you have, is positive, okay, so you have not gone broke, but it's also less than your goal, or your profit is less than 10 grand. As long as this stuff happens, the program should keep going. It should let you keep betting and keep playing. For each round of play, the program should get a bet value, so that's a CN statement, to get from you how much you want to bet. And we should also in this code have sort of like check mechanisms, so we don't want to let the user enter invalid things. So as long as the user enters an invalid bet amount, so more than they currently have, the program should make them retry, should make them give a different amount. The program should generate 2 random numbers for the 2 dice, just as we've done before, compute their sum, and check whether or not the sum is prime. Once all that's done, the program should then update how much money you have according to whether or not you won, and then we just repeat. So we loop, right? We do this on a loop. So that's an English description of what will happen here. So let's just go to the compiler, and let's just sit down and write this. Okay, so let me clear out that output down there because that's annoying. Okay. So, well, at the very least, I need to generate random numbers in this code. So if you know you're going to do that, what you should do is seed the randomness first. So now anything random in this code, the program will look at different places in the random number table every time it chooses. Okay, so now let's just get all of our variables going. Now, here you have to make a choice because money amounts can have decimals, of course, right? You can have $1.50, $2.75, etc. I'm just going to assume that I'm only going to bet whole number amounts. You know, I'm going to bet $5, not $5.50, but you could, of course, write a program that incorporates decimals. I'm going to have a profit variable, and of course, initially I have no profit. So I'm going to initialize my profit variable to 0. I'm going to have a variable that stores my goal. So if I sit down with $100 and my goal is to have $200, then this variable here stores that $200. I'm going to have a variable to store my bet amount, 2 variables for the 2 dice, the sum of the dice, and a variable for the number of rounds. Okay. Oops. Okay, so you see why it's yelling at me? You can't give variables the same name. That confuses it. Okay, so before I go any further, I want to make 2 comments here. First of all, I hope you notice that the more sophisticated your programs are, the more important it is to think about the names of your variables. So suppose that instead of writing bankroll, profit, bankroll goal, etc., I just wrote like A, B, C, D, E, F, G, E, right? I mean, it will be really confusing as you go down the code what each of those means. It's hard to keep track of. But since I've given these things descriptive names, it won't be confusing as we go through the code what each of these guys is keeping track of. So that's comment number 1. The second comment is, I hope you've noticed by now that there are usually dozens of different ways to write a program, right? You just want a program that does X. There are usually dozens of ways to achieve X. So what I'm going to write here is just what I would write, but there are many other legitimate ways to write this program. So I'm just going to model for you what I would do, but it's possible you could come up with some other way that's way different but achieves the same goal. So keep that in mind too. Programming is a creative activity. Okay, there's generally no right or wrong way to do something as long as it does what it's supposed to do. Right? So you can come up with your own way of doing the same thing if you want to. Okay, so keep that in mind. Descriptive names of variables and programming is creative. Right? There are many different paths to the same solution. So the first thing I'm going to have this program do is just ask, how much money are you bringing to the, bringing to the table. So I'm going to get the initial bankroll amount. Okay, so now I'm going to know how much money they're bringing, and then I'm going to ask them for their goal. How much money would you like to leave the table with? So what I'm asking for there is their bankroll goal. Here's the thing though. Well, there are a few things. First of all, suppose that for this first number they enter a 20, and for this number they enter a 5. You know, that doesn't really make sense. You don't want to have as a goal to lose money. I suppose you might, but that would make no sense really, right? So I'm just going to have a little while loop that does this. While the bankroll goal is less than the bankroll itself, and actually less than or equal to, I mean, you really want to make a profit, right? You want to have the bankroll goal be more than the bankroll. I'm just going to tell them, you know, enter a number that is more than what you have. Right? That makes sense. And then we'll let them enter a new bankroll goal. Oops. Okay, so you see the logic of this? They're going to tell you how much money they have. Why would they want to leave with less money than they have? That doesn't make any sense. So if they enter a number here that's smaller, let's just assume they made a mistake and prompt them to keep going until they give us a number that's bigger than what they came in with. Okay. On the other hand, though, so here the bankroll goal is too small. On the other hand, remember that this table has a profit cap. So if you sit down with 10 bucks, your goal cannot be to leave with 10 million bucks. Right? Because that's a profit of more than $10,000. So we need to make sure that the user enters a goal that corresponds with that restriction. Okay, so what is this loop going to do? It says that as long as the bankroll goal is more than the bankroll plus 10 grand, which means that you've made more than 10 grand in profit as your goal. Okay, you can't do that. The table won't let you do that. So let's just tell the user that, you know, you are only allowed to make 10 grand in profit. Please enter another goal. And then let's force them to give it to us again. Okay, so far, what we've done is we've let them say how much money they've brought. Right? Then we've let them define a goal, but now we're forcing them to make sure that their goal makes sense. And actually up here, you know, you might want to think about something like this. If somebody's coming to the table, you know, it wouldn't make sense to bring negative money or no money. So why not tell the user to keep trying? Like if they accidentally enter a 0 or they enter a negative 10, tell them that number doesn't make sense, right? Like, you have to bring some money, right? Try again. And you can force them to enter that bankroll again. Okay, so again, what these three loops are doing is just individually forcing the user to enter something valid. You are not going to exit this loop right here until the user enters something bigger than 0. You're not going to enter this loop right here until the user enters a goal that's more than what they have. You are not going to exit this loop right here until they give you a goal that is not more than 10,000 away from their initial amount, because you can't make that much profit. So let's just pause here and run this to see if it's doing what I claim it does. How much money are you bringing to the table? I'm bringing negative $10. You have to bring some money, right? I'm bringing $0. Well, you have to bring some money, negative $50, right? Okay, so let's just say I bring $100. How much money would you like to leave the table with? Well, I brought 100, but maybe I'm an idiot and I want to lose 50 bucks. Well, enter a number that's more than what you have, please, right? Come on now. 75. Enter a number that's more than what you have, right? Negative 10. More than what you have, please, right? This loop is not going to exit until I enter something that's more than what I have. So let's enter something more than what I have. 15 grand, okay? You are only allowed to make $10,000 in profit, right? So I came to the table with 100 bucks, so I can't leave with 15 grand. So again, I'll try again, right? 20 grand. You're only allowed to make 10 grand in profit. I just told you, right? I mean, please, let me break out of this loop. So let me just enter something like 3 grand now. Okay, now it moved on, right? So we haven't coded past there, but that's what those loops are doing, right? It's just giving you some sort of user validation check, or whatever you want to call it. Okay, so at this point, we've gotten numbers that make sense from the user for their bankroll and their goal. So now, let's actually go into the game playing itself. So as long as our profit is less than 10 grand, and our bankroll has not fallen to 0, and our bankroll is less than our goal, then I want to keep playing this game. Okay, so put another way, as soon as my profit reaches 10 grand, or over 10 grand, okay, as soon as my bankroll falls to 0, as soon as my bankroll achieves my goal, I want to break out of this loop. Okay, so suppose that my profit becomes 10 grand. I'll break out of this loop. Suppose that my bankroll falls to 0. I'll break out of this loop. Suppose that my bankroll reaches my goal or exceeds my goal. Then I'm going to break out of this loop. Okay, but as long as these 3 not winning conditions or not losing conditions, as long as they're all 3 satisfied, I'm just going to keep playing this game. Okay, so again, there are 3 ways for this game to end. Either you go to 0, you lose all your money, you make too much in profit, or you reach your goal. As long as none of those things have happened, I want this loop to keep running. So those are the conditions on my gameplay itself. Inside of the game, the first thing I want to do is let the dealer, or you know, depending on how you set this up, throw the dice. So here I'm doing what I did in the video on random number choosing. If you throw a die, you want a random number between 1 and 6. So this line of code here chooses a random number between 1 and 6, as does this, for each of our dice. And then let's just let the sum be that sum, right? Die 1 plus die 2. So I generate 2 rolls for the 2 dice. I compute their sum. And now let's just ask the user, how much would you like to bet? Let's get their bet from them. So again here, there needs to be some checks in place. So you can't just bet anything. In particular, you can't bet more money than you have. So let's just have a while loop that does this. If you bet more than you have, or you do something stupid like bet nothing or a negative number, you know, see how like, come on bro, don't do that. Right? I mean, you want the user to enter something that makes sense, like always. So, oops, sorry, I wrote a B instead of a bet. Let me fix that. So if they're going to enter a negative bet or a 0 bet, that doesn't make any sense. If they're going to bet more than they have, they shouldn't do that, right? And so actually, let me break this into 2 separate if statements just to make it more precise. If bet was bigger than bankroll, let's just tell them, you know, you can't bet more than you have. You're not allowed to do that. And then let's get the bet from them again. So try again. And then if that bet is less than or equal to 0, if the bet is equal to 0, let's just tell them you have, oops, quotation marks, well, you got to bet something, right? And otherwise, so in the case that they enter something negative, right, so I can actually explicitly write it if I want to, else if the bet was negative, we can tell them you can't make a negative bet, oops, negative bet, try again. Okay, so again, let's just process what's happening here. Every time this program runs, I'm going to generate 2 dice. I'm going to look at their sum. I'm going to get a bet from the user, and as long as the user's bet doesn't make sense, I have to check them on it, right? As long as they bet more than they have, or they're betting nothing or something negative, you're going to tell them, look, you can't bet more than you have. Please try again. And then I'm going to loop back up, and if it's still invalid, it's going to keep looping here, right? Until their bet amount becomes something legitimate. Okay. Oh. Right, so you're seeing me in process here, right? So notice you have to give them an option to redo their bet if you're going to yell at them, right? So that needs to be in each of these if statements. You can't bet more than you have, try again, let them try again, right? You got to bet something, try again, let them try again. You can't make a negative bet, try again, let them try again. Otherwise, this loop could be infinite if you don't let them update their bet. Okay, so this loop checks to make sure their bet makes sense, and now I move on. Once you have their bet, what do you need to do? You need to check whether or not they won to know whether or not they get money or they lost money. Well, the way you check if they won or not is to check whether or not the sum is prime. Okay, and so you guys have now written a program that checks whether or not a number is prime. So at this point, you can actually just copy and paste that code in, but let me just show you a quick way to do this. So basically what I'm going to do here, I'm going to set up a loop that, first actually I'm going to tell let me copy and paste this. First I'm just going to tell the user what happened. So the dice rolled die 1 value, die 2 value, for a sum of sum. Okay, so I've told them what happened, right? Now I want to check whether or not that sum is prime. And the way I'm going to do it is I'm just going to set up a loop that is similar to what you guys did. It's just going to go, it's going to start by trying to divide the sum value by 2, then try to divide the sum value by 3, sum value by 4, etc. So if sum percentage divisor is 0, so in other words you found the divisor between 2 and the number less than sum, the way I'm going to record that is by changing the value of x to 1. So notice I declared a variable x here. The only reason I introduced that variable was it's a dummy variable, and it's just going to record whether or not I got a hit when I was checking for divisors. Because remember, right, if you want to check if a number is prime, you can just divide that number by all of its potential divisors, and if you ever get a hit where the remainder was 0, all I'm going to do is change the value from 0 to 1 of x. So x is just a dummy variable that I'm going to change the value if I got a hit. Okay, and once I divide sum by 2, I now want to divide sum by 3, sum by 4, sum by 6, etc. So this is just a really small loop that kind of streamlines what I saw a lot of you doing with your prime number program. But anyway, this is just going to check whether or not sum is prime. So notice that if you get a hit, then sum is not prime. So if x equals 1, that's the way I'm recording that I got a divisor. So that's the way I'm recording it's not prime. Well, if you get a number that's not prime, then you lose. And if you lose, then the amount of money you have, now you have to take your bet out of it. So if you had 20 bucks and you bet 5 bucks, the new value of your bankroll is 20 minus 5. And similarly, whatever profit you've made, you have to take the bet out of it because you lost. But if x is still 0, what does that mean, right? Because I made x equal to 0. If x is still 0, what that means is that I didn't find any divisors because the value of x did not change. So if x is still 0, I found no divisors. That means that the number was prime, so I won. So let me just, oops. So I up my bankroll by my bet amount, and I up my profit by my bet amount. Okay. So now I have checked whether or not I won. If I won, I increased my bankroll and my profit by my bet amount. But if I lost, I decreased my bankroll and my profit amount by my bet amount. So now here at the end, let's just, your bankroll is now, let's tell the user what they're at. I guess we should put a little $sign there. And just to clear some space the next time the loop runs, let's have a couple of new lines. Okay, so unless I've made a mistake, and I mean, I am who I am, so surely not, right? Unless I made a mistake, this should do what I claim it does. It should let us play this game. So let's just run it and see what it does. How much money are you bringing to the table? Let's sit down with 50 bucks. Okay, low stakes. I want to leave with 100 bucks, so I want to double my money. I'm going to bet 25 bucks first time, right? The dice rolled 1-6 for a sum of 7. Sweet, I won, because 7 is prime. Your bankroll is now 75 bucks. Oh man, let's do this again. Let's bet 50 bucks. Let's try to leave with that 100 bucks. Oh man, dice rolled 4-4 for a sum of 8. Man, so my bankroll, I lost 50 bucks off of it. So it used to be 75, now it's 25. How much do you want to bet? Let's go big or go home, right? Let's bet it all. 25 bucks. Oh man, I got a prime number, right? So I guess while we're running this, we should make sure that all of our user checks are in place. So it says your bankroll is 50 bucks. How much would you like to bet? I want to bet 75 bucks. It says you can't bet more than you have, right? Oh man, 100 bucks. Can't bet more than you have, right? You only have 50 bucks. So let's bet 50. Oh man, rolled 5-3 for a sum of 8. Your bankroll is now 0. Oh, I lost. And so you notice now the program exited. Okay, so that's cute, right? So it did what I wanted. And so of course you can embellish this like down here, you know, like you can have if bankroll is 0, you can have the program output things like, you know, that means you lost, right? Else if your bankroll is greater than or equal to your goal, you can have it output, you know, congrats, you won, you know, whatever. All right, so after you break out of the playing loop, you can now summarize for the loser, or you can summarize for the user what happened, right? Else if, right, so anyway, so we can tell them whether or not they won or lost once we break out by knowing what our bankroll is. You know, we either reached our goal or we didn't, or even in the case of 10 grand, right, we either reached our goal or we didn't, and so it will now tell us what we did. So let's just run this again, right? 50 bucks, 100 bucks. I'm going to bet 50 bucks. Sum of 6, your bankroll is now 0. Loser, out, right? Let's see if I can win one of these. 50 bucks, 100 bucks. I want to bet 50 bucks. So I either win or lose on this one round. Oh man, I lost again. Let's try one more time to see if I can actually get it to win. Ah, right? Dice rolled 1-4 for a sum of 5. 5 is prime. My bankroll is now 100 bucks. So I have to leave with my goal. Right? Congrats, you won. Okay, so anyway, so there's sort of the process, right? You sort of think through what you need to happen, and then you just sort of lay out the code, right? So this is probably the most sophisticated program we've had this semester, solely in terms of its length, right? And notice all the loops all over the place, right? You have, right here, you have an if inside of a while inside of a while. So that's twice nesting there, and you have random numbers being generated every time you run this loop, etc. Here's another if inside of a while, and this while right here is inside of this while, right? Okay, so hopefully watching me write this program has helped tie these concepts together for you, and hopefully now you're starting to see the power of these concepts.